Hello, and welcome to update number 4 of the Zig Clr project. And I'm really excited because finally we have some memory safety protections and memory safety analysis. So what I completed was stack pointer and escape analysis. And so let's take a look at an example of an escaped stack pointer, as is highlighted in this code here. So what's going to happen is we're going to call this escaped param pointer function. And then this value 20 is going to be placed in this parameter here. And then we're going to return a pointer to that parameter value. And that is, of course, a stack pointer because all parameters are put on the stack. This is an illegal operation. Now, why is it illegal? Because when you leave the function, all of the elements in the stack should be gone. And you can, if you provide a pointer to this, you can wind up in a situation where you leak information that you shouldn't be leaking, that other code should not have access to. What happens if we actually run this program? Well, if we run this program, we don't get any sort of weird errors, but we did get an exit code. And so let's look at what that exit code is. It's 20, and that comes from here because that pointer still was in a slot of memory that didn't itself disappear, didn't get any sort of boundaries for it. And so we were able to access it even though we probably shouldn't have. So let's run analysis on this. And if you want to know what run1.sh does, you should watch the previous video, update number 3, where I go over in detail at the beginning what run1.sh does. So let's run the analysis. And here we see it reports that there is a stack pointer escape in the escaped param pointer function. It occurs on line 2, column 4. That's right here. And it tells us that the pointer was for the parameter param created in that same function on line 1. So that's right here. And what's really helpful that I didn't have before is now we have tracking of variable names. So this will help you hone in on exactly where the stack pointer came from that wound up escaping the function. OK, let's look at another example. And this is a stack pointer that came from a variable instead of one that comes from a parameter. And it's all the same, except instead of having a parameter, we have this var foo. And then we take the pointer from the foo variable right here, and then we return that pointer. Now, just to bear in mind that like passing a pointer to something on the stack isn't itself generally an illegal operation, right? I can pass that pointer to any function that gets called because that function then may decide to like set the variable if it's like an in-out parameter. So that is a useful thing. For example, you may want to set a variable to be undefined and then put a value in it by calling another function that sets the value inside that pointer. That's perfectly valid. But what the problem is we can't return it coming out of that. So let's run this one. And here we can see it reports a stack pointer escape on line 4. That's right here. And it reports that the pointer was for local variable foo right here, which was set on line 2, which is correct. So that's what I achieved on this sprint. The next sprint is going to be doing create and destroy functions for allocators. If you like this content, please like this video or subscribe to the channel. And if you support having more analysis, static analysis of Zig code, especially to find memory safety violations, I have a sponsorship link in the box below. Thank you very much.